Consider the following function. F of x equals minus 4 times x squared plus 16 times x plus 9. Here's a question. What is Laplace transform of this function? Well, a long way to answer this question would be to apply the definition of Laplace transform and compute the necessary integrals and then get the answer. There is, however, a much shorter way which makes use of the theory of Laplace transforms. Specifically, we are going to make use of existing formulas and the property of linearity of a Laplace transform. Okay, so which existing formulas are we referring to here? To come to that, first let us apply linearity. So by the principle of linearity, what we can do is the following. If I want to evaluate Laplace transform of minus 4x squared plus 16x plus 9, by linearity I can evaluate each individual function in this linear combination and then take the same linear combination of those evaluated functions. So we'll have then minus 4 times Laplace transform of x squared plus 16 Laplace transform of x plus 9 Laplace transform of 1. After this, what we're going to do is to use the formulas we have for computing Laplace transforms of these kinds. What are these formulas? They all actually come out from the very same formula that says that Laplace transform of x to some power n, irrespective of what the power is, but it has to be a natural number starting from 1 onwards, is equal to n factorial divided by s to the power n plus 1. So this is a formula that can be derived in general by applying the definition of Laplace transform. We would also have to make use of mathematical induction to establish validity of the formula for all values of n. And then once we have the formula, we can then start applying it in specific cases. And in particular in this case, what we need is the case of n being equal to 2. So the formula will give us 2 factorial divided by s to the power 2 plus 1. In here, we need to take, as we can see here, we've got x, so we want n to be equal to 1. And so the answer will be 1 factorial divided by s to the power 1 plus 1. And in the last one, we have 1, and we want to compare that with x to the power n. And so it is clear that n has to be equal to 0 in order for x to the power n to be equal to 1. And so we can apply that. We get 0 factorial over s to the power 0 plus 1. Earlier I said that the formula only works when n is a natural number starting from 1. Actually, it also works when n is a natural number starting from 0. Of course, to apply... Okay, I can see here I'm not able to fit this, so let me remove it from there and put it instead here. When n is 0, 1, 2, and so on, in all of these cases, Laplace transform of x to the power n is given by this formula. Of course, when n is 0, 0 factorial needs to be defined, and it is defined. 0 factorial is equal to 1. In case you didn't know, 0 factorial is equal to 1. And so we can proceed with the calculation then and say that this thing is equal to minus 4 times 2 factorial is 2, so it's 2 over s to the power. We had here 2 plus 1, and that's 3, so it's s cubed, plus 16 multiplied by 1 factorial is 1, so it's 1 over s squared, and then in the end we have 1 over, 9 actually, 9 times 1 over s. So that is the value for Laplace transform of f when f is minus 4x squared plus 16x plus 9. And the way we got this was to, on one hand, firstly, use linearity to break down the Laplace transform of this longer, more complicated expression into a linear combination of Laplace transforms of more basic expressions, and then in each case to apply a formula that we have derived previously for general functions of a certain kind. So of course this method cannot work with expressions that are not linear combinations. In case you didn't study linearity, let me point out to you that if we have something like Laplace transform of x times x, it is not equal to Laplace transform of x multiplied by Laplace transform of x. Do we see why? Well, we can already from the previous formulas derive this inequality, so this non-equality rather. So L of x times x is x squared, is of course x times x is x squared, so L of x squared is 2 over s cubed, and that definitely isn't equal to L of x times L of x, and L of x is 1 over s squared, so that's definitely not equal to 1 over s squared times 1 over s squared. You can see clearly that these things are not equal. And so the difference between this kind of thing and that kind of thing is that in the first one we had a linear combination of functions. That means that the functions were not multiplied by each other, rather they were multiplied by some constants and then added. So you are only allowed to multiply by a constant your function and then add the functions together. This is what is allowed in a linear combination. You're not allowed to multiply them together. And so Laplace transform is not going to break down into a combination of more simpler transforms when your expression is not a linear combination of the more basic ones. Great. Okay, so my instinct tells me to ask you if I have any questions, but obviously you cannot tell me now because the time that I'm recording this video is not the time that you're watching it. But surely if you have any questions, you can communicate them through forums or the chat. All the best.